Jeffrey Ziegler is an assistant professor in political science and data science at Trinity College Dublin. We're very excited to have him here with us today. In his research, he extends computational and quantitative methods to the social sciences, focusing on multimedia data such as text, audio, images, and experiments. He applies these techniques to study questions related to political and psychological behavior.
All right, thanks so much. I really appreciate being here with you guys today. So I know that's a lot of technical jargon, but basically what I want to walk through is one, why you would want to use an attention check at all in an experiment, and then basically what are the traditional ways that we have to measure attention, and then what are some benefits of maybe using an open-ended response instead of closed-ended responses. I know this is a little bit of a smaller group, so I don't know if everyone is running experiments day to day in their own research. If you have, you probably have run across the issue of having respondents who are potentially inattentive to the entire survey, but more specifically, potentially to an experimental arm that you're interested in seeing, whether basically the effect of receiving that treatment, how that influences some outcome. So the current solution, like I said, is actually using many factual or instructional closed-ended manipulation checks. This could include asking individuals, again, factual questions like what color is the sky? Instructional would be more along the lines of, please ignore this prompt entirely and select the first option, essentially trying to see if someone is reading the prompt pretty closely. This sounds pretty good at first, but then there are some issues with this. The first of which is there's only two possible outcomes here, right? You can either be incorrect or correct. There's not really any differentiation in, quote, attention per se. That means it's prone to guessing. I could, if there are only two options, I have basically a 50% chance, even if I know it, of getting it correct. You can add more options, which does maybe decrease the likelihood of guessing. But again, there still is, even with four options, a pretty high likelihood that someone could pass, even though they're not being attentive to the question at hand. And then the third potential problem is that there is inherently less variation. So again, we can think about including more options potentially, but that just gets rid of any issues with guessing. We still would only be able to say this person is attentive or not attentive. We could add in two questions. So maybe they could be 50% attentive, but at some point we're gonna, one, lose a lot of space in our survey, which is very costly, and something that I'm cognizant of as someone who doesn't have like an unlimited research budget. And then the second thing would be that, again, you just can't have, even if you are able to add 10 different questions that would measure attention, that's only, 1 out of 10, 2 out of 10. It's still not really accounting for a wider range or variation that likely exists in attention in your sample or the population at large. So my solution to this is using open-ended manipulation checks, in which you basically are just asking individuals to restate what they read on a previous page. And I'll talk about different ways that we could potentially apply open-ended questions to audio or video, but just for right now, we're thinking about this as text. So attention is literally going to be the distance from what someone reads, and I'm calling that a prompt, and what a respondent recalls as what they read. So pretty simple setup here. This is really nice because, one, we have a continuous from 0 to 1 measure of attention. Also, it's bounded then between those metrics. We are allowing for greater variation because, again, someone's attention could take on any value infinitely between 0 and 1. Maybe not infinitely, mostly because of the strategies that we're using to calculate distance, but a much larger degree of variation. And it is especially larger for techniques like word embeddings. The third thing that is actually really nice here is that we are essentially not entirely removing our reliance on humans to analyze these responses, but the method that I've developed really reduces the reliance on humans to analyze these responses. So in many instances, I think in previous work, many times people would not want to use an open-ended response because they would have to manually code whether or not that response was correct. And so using a text as data approach here and actually calculating distances, we're kind of overcoming that issue. That's not to say that you should give up on using human coders entirely, mostly because I think it provides a really good baseline to make sure that these automated processes are working correctly. But again, it's going to really reduce the reliance on humans to get it right, per se, because there's going to be a lot of intercoder differences in what actually is a, quote, correct answer for an open-ended response. And then last, what's really nice is now that we actually have a measure between 0 and 1 that calculates attention, we can then see how inattentive workers are actually impacting potentially the overall results. So this is really getting to the heart of whether or not you as a researcher are interested in saying something about how your sample speaks to a larger effect in a population where you may have a mixture of attentive and inattentive individuals, or whether or not you're interested in just estimating an effect among those respondents who likely receive a treatment. So your compliers, so to speak. And, oh, I kind of preempted myself there again. So what we're able to do is that we're gonna then assess the difference in the ATE, the average treatment effect of respondents who likely receive a treatment, and then those who don't receive the treatment. And finally, I have developed an R package. I have to admit, this is still very much a work in progress, like most R packages. The more I develop, the more I need to expand it. But right now, all of the suggestions that I'm going to talk about today are executable in R. So to start off, this is what I think is a very simple setup. One, we need a prompt, so something that individuals are going to read. This could be an instruction, like you need to regurgitate exactly this on the next page, or it could be a story in text. So what's really nice is that the prompt here could actually be a text treatment that you're interested in seeing. If individuals pay attention to my treatment, what then is the effect of that treatment on those individuals? So this can be used for a multitude of different purposes. Basically moving forward though, I'm going to be operating kind of not under the assumption, but I'm going to be working with the second type of scenario where the prompt is actually a text treatment embedded in a survey. So again, I'm interested in seeing how individuals who pay attention to the treatment actually end up responding and how that may differ from those people who are not attentive. So once we have what individuals read, we also need to ask them to restate the content that they viewed on the previous page. This is good because we are not priming them to say anything about actually what was on the page. People are receiving all of the same information. So again, no one is going to be differentially impacted by asking them to restate the prompt. So part of this only works because one, all the respondents need to receive some text as prompt. Obviously, we can't have a comparison of how attentive someone is in their recall if they never read anything. So that is, well, that would be another gripe of mine if your control is not providing anyone with text, but that's a different problem for a different day. Basically, this is just saying everyone needs to receive some type of text. That should already be baked into your experiment. The second thing would be that there's no attrition between the prompt and the response. So you can't have any individuals who are essentially opting out of the process of recall. Again, because those would be a certain type of individual. And if they left our survey in general, then that's going to basically bias our estimate of individuals receiving treatment. This shouldn't really be too much of a problem. I don't think, at least in the US, you're not allowed technically to force people to continue in a survey if they don't want to, but this is definitely something that you can check after you've run your survey. And in both the original survey that I conducted and the replication, this wasn't an issue. And then this is maybe the more important thing. We need to assume that attention is not going to be, people are not going to be differentially impacted to respond or recall based on what prompt they read. So this will make a little bit more sense when I actually bring up the example, but essentially we have Democrats and Republicans, and we think that they may be more likely to want to read news stories based on essentially the content as well as their own personal preferences. So we can't basically say that we need it to be the case that a Democrat is going to be just as likely to say or record something as the response if they read an article about a Republican or a Democrat, basically. So again, this is an assumption, but we can check on average, basically, is the attention different based on these different characteristics? And so again, I go through the steps of doing that with the replication, but basically none of the respondents on average are more likely to be attentive based on the prompt that they received. So if all of these assumptions are met, then we can use that prompt as our text treatment. And again, that's really nice because we can see how closely people are being attentive to the thing that we care about, what we're manipulating, and we can see essentially how attentiveness may differentially impact our outcome. Okay, so now that we have our setup, we basically need to figure out how are we going to measure attention from text. There are a couple of ways that I recommend doing this. First, always go with the easiest, and that's going to be a bag of words approach. So some of you may be familiar with this, so I'm sorry if this is a little slow or benign, but I think this is a really good example of how this works. So when we're using a bag of words with n equals 3, that means that our quote window is going to be 3 letters or characters long. So we'll start off in the first kind of n gram, because again, these can differ based on the number. This would be a trigram. So the first one would be BAN, and then ANA. So again, literally just moving one letter at a time here and transitioning the window. So we have 4 different n-grams here that pop up for the word banana. Now, if we are counting them as unique grams, we actually only have 3 unique grams. And so this is the way that we'd actually end up recording this if it was the prompt. So we'd have 3, and then the count would be 1, 1, and 2. Now, you can imagine someone who is responding, they may be paying close enough attention and they make like a typographical error here. So they accidentally put in D in between the N and the A there. And we basically end up getting the exact same first part here and even the second, not the second, and the last, I apologize. But again, the count is going to be different. So this can actually dramatically throw off an individual. There are 2 different measures that we're going to use. One is going to be a Jacquard. So literally just counting up the same unique n-grams over the total number of n-grams. So for this, it would literally just be 1 over like 8, I think. 1, 2, 3, 4, 5, 6, 7. Yeah. Okay. Then we could potentially also see a problem with this, right? If I basically just increase my denominator and I increase my numerator, like longer words essentially could end up being more common, or longer recalls or phrases, sorry, not words, could end up generating a closer similarity, even though they aren't necessarily actually sharing more n-grams. And so that's what a cosine is doing here. We're just basically standardizing over the amount of n-grams here. All right. Now, there's a couple of different things. Since there are many, I've only talked about 2. Those are the 2 main ones that I use in the paper. I also talk about different types of bag of words approaches that you could use. They are incredibly highly correlated with both the Jacquard and the cosine. However, again, because they have different properties, I try to take the best of both worlds. And really what I do is take an average. And then there's also a little bit of a severity for downweighting inattentive participants that I add in. And I'm happy to talk about that a little bit more. I think it's probably more nitty gritty than anything. The main thing that we want to pull away from here is that we are essentially, again, just using the text from the prompt and the recall and using the distance between those as a measure of attention. You could also imagine a world in which maybe they use completely separate words entirely to express themselves, and maybe someone read an article like, well, actually, this is the example coming up, like Donald Trump was angering conservatives within his party. You could express that, but say the president was in disagreement with other members of his caucus. So basically, all different words, exact same meaning. We could use word embeddings then as a way of calculating a distance. And again, we'd be using a cosine similarity. So these would be comparable metrics. And again, I'm happy to talk about why I use one over the other. Basically, the short and skinny of it is bag of words are computationally much cheaper. Word embeddings take a lot longer to run. Usually with samples that you're running, like maybe 1,000 respondents, it shouldn't be that dramatic. But even for the project that I was doing, otherwise, there were 5,000 respondents. So that actually ended up being pretty costly, at least time-wise. And then also just ease of interpretation. I think it's much clearer what's happening with a bag of words approach. So again, there's not really much difference here, especially in how they perform, but that could just be specific to this case. So I don't want to say use bag of words every time. It should be adjusted for what's better for your scenario. So now that we have the construction, exactly what we're going to do with regard to measuring attention, I want to go over the replication or application, and then show how the effects may differ actually based on attention. So the replication that I'm going to be talking about is one that comes from John Kane in a recent article that he just published in PRQ. And basically his research question is, do partisans select negative or positive political news stories? The idea being that if I, again, am a Democrat, I should be more likely to want to read positive stories about my in-group, but also potentially negative stories about my out-group. And so the same should hold for Republicans. So in this case, Republicans should be more likely to want to not read this news story about President Trump recently upsetting many of his conservative supporters. The other version of that would be him basically making his conservative supporters happy. So the manipulation here is essentially unity within the Republican Party, disunity within the Republican Party, and then I believe the neutral one was biographical information about President Trump. So the outcome that the author was originally interested in was just whether or not people wanted to read the news story about President Trump or not. So the outcome here is just binary 1 or 0. Now, just to give you an idea, one, that these measures of attention actually have some validity to what we as humans would deem, quote, more correct. So I want to convince you that going from like 0, that would be very inattentive, and then moving towards 1, we progressively get more attentive. The thing is that it's hard to say, right? When does correctness kick in? That's not really the goal here. It's, again, to try to give you some better variation in potential attention. So we can pick out a couple of instances, and I picked one here that is really low, has a 0.08 cosine score. And the prompt that they read was the pleasing or unity within the Conservative Party. So their written response essentially only overlapped with Trump. Everything beyond that was completely different. And you can even see that the meaning is different. It's not that they're just missing the words, but the sentiment is the same. So in that sense, good things that are closer to 0 appear to be less attentive. Then we can look higher at the distribution. So maybe 0.79, this person received a prompt about basic biographical information, and they almost exactly replicated the prompt. The only thing I think they missed was biographical information about President Trump, biographical. Yeah, I don't even think they missed much. I think it might be, yeah, it's, basic. They missed the word basic. So almost exactly on point. Now, that is just the cosine similarity. I want to show you that the cosine similarity, one, is very close to the Chicard similarity. So they're almost perfectly correlated with each other. And then the second thing to glean out of this graph is, again, scores that are closer to 0 are going to be more likely to us as humans to be incorrect. So the differentiation here is actually based on human coders who went through the open-ended responses and deemed whether or not the individuals were attentive or not. So again, this is why I hesitate to give you kind of like a threshold of what actually constitutes attentiveness, because you can see individuals that even got a 0.5 by a human coder, they were deemed to be incorrect. So that could have been an instance of maybe genuine incorrectness, or more likely, it's a problem with intercoder reliability and just the fact that it's really hard to say at what point is this correct and at what point is this incorrect. Now, to kind of get toward that end, I will talk about actually creating a sampling distribution of compliers and non-compliers. But before we do that, I just want to see if the results are different at all based on whether or not we essentially are weighting or, quote, removing individuals based on attentiveness. So this is a very these are basically two common strategies that people for, forever basically have taken, and rightfully so. One, if you don't necessarily care about attentiveness, which would be the main results. So the full sample, black triangles, that is exactly replicating the results that were found in the original paper. So the author hypothesized that Democrats would prefer to read things about a disunited Republican Party, which we do see here in the left panel. However, we don't see a similar effect among Republicans wanting to read positive news stories about their own party. So the author in the original paper was basically like, I only found evidence to support my first hypothesis. And even though without the regression, their unconditional means of just diff and diff showed that there was actually a difference in Republicans wanting to read positive news stories, that seemed to wash out. And so they just kind of moved on in the original paper. Okay. So if we use the attention as actual weights in a regression, and again, I'm not saying this should be the final product, but we would be much less concerned if we ran this and none of our estimates changed between results. That would be great, because that would mean that attentive individuals are not answering the outcome question in a different way than inattentive respondents. We do see that happening. And now it kind of begs the question, who's driving the results? That would be the next step. And so in order to do that, we are going to create a sampling distribution for the average treatment effect of compliers, AKA like the local average treatment effect. And what's really nice is because when we take a sampling distribution, rather than doing like an instrumental variable approach, we can actually end up getting a distribution for the non-compliers as well. And that's going to be really informative here, especially because we're talking about inattention. So if people are being inattentive, they should just be guessing a lot of times. So this is going to seem potentially like a complicated process, but really, again, I'm just sampling the distribution of the local average treatment effect. So to do that, first, what I'm going to do is because it's very difficult to create a threshold of who is a complier and a non-complier, I'm kind of taking that out of the equation and basically randomly assigning that cutoff value each round. So one round, someone may be a complier, some round, someone may be a non-complier. This should actually create a tougher test for us because we're actually mixing in compliers and non-compliers potentially together and messing it up. So again, like there should be potentially less separation than more in this using this strategy. What we'll do then is once we have decided you are a complier, you're a non-complier, we'll estimate the regression model, pull out the average treatment effect for individuals above and then below the threshold, keep that, and then we'll rerun this for however many rounds of the simulation we want. Again, in the paper, I only use 100. It basically to your discretion on how much you feel like you need to sample the, credible space of where you think the threshold of complier and non-complier lies. So in mine, again, it was pretty clear cut. You could see there were very little instances of individuals being labeled incorrect past a certain threshold. So 100 was sufficient for me, but again, you could run more. And once we've run 100 simulations, that means we should have 100 estimated ATEs for compliers and non-compliers. And now we actually have a distribution, which is really nice, again, because with an IV approach, we're basically assuming that attention, the effective attention is incrementally linear. And we're not necessarily making that assumption here. If they end up being the same, then awesome, we'd still end up finding that out. All right, so when we actually see who is ending up driving these results, let's first just look at the compliers. The compliers, one, the distributions are much more, they're much tighter. So the certainty around our estimates, it looks better. The second thing would be that they are conforming much more like what we would expect under the author's original hypotheses. Basically, when individuals are actually paying attention to the news stories that they're reading, they're acting in a way that we would have hypothesized prior to running the experiment. So you can see here that, again, Democrats are more likely to want to read disunited, so negative news stories about the Republican Party, and then they actually actively move away from stories that are positive about the Republican Party. The Republicans also act in the way that we would anticipate, where they're just more likely to want to read positive news stories about their party. What I find really interesting is there was a null in the original paper with independence. And the author basically just chalked that up to kind of an indifference. Well, what's really funny is that in comparison to the control category, it seems like independents actually prefer apolitical news in general. So they're less likely to want to select any political news. So that, I think, is an interesting finding that you wouldn't necessarily see if we were looking at the overall results using compliers and non-compliers. Now, if we look at the non-compliers, we can really see why our results were pretty muddy in the first place, because they are, in some cases, actively acting counter to how we would anticipate. Or they're basically guessing in a lot of instances. So there seems to be a lot of random noise, the distribution is split. Again, this could be an artifact of how we are selecting our cutoffs, but I think it's probably pretty clear here that in general, non-compliers are one, guessing and adding noise to the average treatment effects. So if you are interested in how individuals who are paying attention to your treatment are acting, this is a really good way at getting at that. Now, to summarize, this is kind of my last ditch sales pitch to you, to use this in your own research. But if you already are using humans to code your open-ended manipulation checks, I would urge you to try using this because, one, it's more systematic. Two, it's replicable in the sense that any person will pick up your code and be able to get the exact same answer. It's not going to be dependent on who your coders are. And it's transferable. When I say transferable, I mean essentially across contexts. We're able to use it in any different language. It's going to be transferable, again, to using it as a manipulation check of a treatment. You could use it prior to a treatment if you're scared about doing that and you just want to measure attention more generally. So again, if you're using humans already to code open-ended manipulation checks, highly recommend using an automated process to do it. If you are still really wedded to using your close-ended manipulation checks, I would beg of you to change because, one, unless you're able to add in 5 or 10, you're really limiting the potential variation of respondents to express how attentive they are. That's really the big thing. The other thing would be that you're much less likely to end up getting people who are able to fake being attentive. As long as you're making sure that people can't copy and paste, that would be maybe the only thing that I could think of, but I don't know how many people are going through and copying every question down before they answer the next one. So again, like this, it's just much less likely to fall prey to guessing. And even if you don't believe that an open-ended attention check would be better for allowing more variation or guessing, you can't really actually investigate using a closed-ended manipulation check how inattentive participants are impacting your overall results. So that, I think, is actually the really big selling point, is being able to use the open-ended manipulation check with whatever treatment you're actually interested in manipulating in the survey. So this is also to say that I don't think the use of open-ended manipulation checks is just for text. I've just shown you an example where everything was in English, but basically if you have any written alphabet, I don't know how well this would work with characters. So someone who does text analysis with distance metrics with character languages would probably know better. I'm sure there's something out there, but you wouldn't be able to use the same strategy that I'm doing. As long as there's a written alphabet, though, it would work. So even for things like Korean, that would work. I think basically Mandarin is kind of the only issue that you may have. So kind of as a proof of concept, if anyone dips into the appendix, there are survey experiments that I have done an open-ended manipulation check in both Brazilian Portuguese and in Spanish. And I am currently working on a comparison basically of when you may want to use a closed versus open-ended manipulation check, but kind of to, there's no surprise here that I clearly favor an open-ended manipulation check, and I actually quite frankly can't think of an instance in which you prefer to have a closed. The other nice thing would be extending this to other forms of treatments that you have. So we've talked about using text similarity, but you can also imagine that you can have audio similarity as well. Audio obviously has text embedded in it, as well as other things like pitch and cadence. And we can create similarity metrics for those as well, which is really interesting. So right now I'm working on a project that actually is comparing attention checks using text and then a text treatment and then an audio treatment as well in the context of US Supreme Court hearings. This is also really interesting for me because I think it can be applied to other types of interview processes. So as long as you have audio, you have text, that could pop up in phone interviews. So if you're running a really long phone interview and you're really interested to see if someone's paying attention to that one question at hand, or even for field experiments. So I really think like the bounds of open-ended manipulation checks are pretty unchecked at this point. So with that, I'd like to thank you for your attention, and I'm happy to take any of your questions.
Thank you so much. That was very, very interesting. I'm gonna see, I have a couple of questions if our audience does not. I was kind of interested in hearing you while our audience thinks of questions they may have. I was interested in hearing you talk a little bit more generally about your experience with inattentiveness and how widespread it is. And if you have any sense of, at one point in your talk, you referred to respondents as workers, which is telling, right? They're M-Turkers, they're at work. And so I guess I was curious if you could talk a little bit about kind of this as a problem on different types of platforms, or is it kind of the same problem everywhere, whether it's someone on MTurk or someone on an Ipsos panel or some other type of panel? Are you familiar with kind of like variation in this as a problem across different platforms?
Yeah, no, you're definitely correct in the sense that cognizantly or not, I definitely am, I know who a lot of these people are. And yes, they are in a lot of instances, this is only one of their many working tasks, even in that hour. So I think, like you said, it's probably less of an issue for panel surveys potentially, where there's less of a time crunch on them completing this task this second and getting on to the next hit so they get their money. There is much more of an incentive when you are just one of hundreds of requests that someone's filling out in a day. As far as different types of platforms that this is a problem on, so the replication that I did, they originally, I believe, used mTurkers. So clearly enough of a problem that I think when I showed this to the author, who I believe ended up being, I know it was a reviewer on this. He was basically like, thank you for saving me. First of all, like, I was right. But the second thing was basically, wow, I didn't realize how bad of an issue this was. Because even when he had hand coded the open-ended responses, I think, again, you can almost kind of convince yourself that it's not a problem if you change the goalpost of what's correct and incorrect. So depending on how harsh those RAs were, that would kind of determine how worrisome this was. However, with platforms, I used a platform for my dissertation, actually, where I thought it would be less of an issue. And this is actually what I developed it for, is because I didn't want to waste a bunch of time, because I figured people were paying attention because they were part of basically, not a panel survey, but like a panel of surveys. So I thought it would be less of an issue. Not the case. So it's hard to say where it may be better. I can definitely tell you from experience that platforms like Lucid are especially problematic, where even people who were running close-ended manipulation checks were finding that nearly 50% of their respondents were failing. So I don't know. I think this was all over Twitter. So I think they were actually getting responses from Lucid and they were doing a better job. I don't know if that has changed. But I also think a lot of this might be temporal as well. These studies that I'm talking about were done before the pandemic. And I think, if anything, newer workers have been introduced into this model, and I'm not sure if that has led to higher quality. So I guess the long answer is I think it's very pervasive. I think it's so pervasive that I think we should be doing these things in other types of interview scenarios. I can't see why, if someone can barely keep their attention through a 5 or 10 minute online survey, what about phone interviews that go on for 20 minutes, or a field interview that's almost an hour long or something like that? Yeah, I have to believe that it's more pervasive than we would like to let on. And again, that's not necessarily a problem if you think that it is of the same percentage as you would see in the population. That's the part that I'm not convinced about. So as far as I'm concerned, it's just better to get a measure of it. And that way you can tell if it is or it isn't, and then you can move on from there.
Excellent. Reagan, did you still have a question?
Yeah, thank you for your talk. I just had I guess I'm going off of Michelle's question on platforms. Like, I noticed like Qualtrics, they'll give you like how long it takes each respondent to answer a question. In terms of like your model, do you find like, have you like included that in your like how you measure attentiveness, or is that, do you find that running the same issue?
No, you're totally on the ball. And I wish I had had the foresight to think of this, because I think, I don't know where it recently came out, but there's a paper basically saying that I don't know if it's the time that it takes an individual for each question. I think they look at the total time of a survey response and look at how long it should take individuals and basically use that as a metric of attention. But I guess to me, almost always the proxies for attention aren't really what we like want to get at. So that's why I definitely agree. So one, I want to have this. And so that's kind of in the comparison of closed versus open-ended projects, as I'm looking at basically as time correlated with attentiveness, because there's definitely a correlation between correctness and speed. But again, it's still not clear to me if someone takes 15 seconds but answers correctly, then that's what we want, right? So I definitely I agree. I want to basically have more ammunition to tell you basically that attention isn't necessarily correlated with the time that it takes. But yeah, I don't really have any good intuition, because you're right. I could record that data. Unfortunately, I couldn't do that, at least in the replication.
Thank you. Oh, sorry.
No, go ahead, Reagan.
I just have another question in terms of like these prompts. When you include them into the survey, do you find that like the number of respondents decreases? Like I saw, like you said, talked about like prompts and responses, keeping those like with attrition, but like in terms of like if someone sees that initial prompt and just exits the survey?
Yeah, so that would be an issue. So we can't have that. And it's definitely, one, it's an assumption, but it's an assumption that we need to make for, I think, the reason why you're asking, which would be the type of person who would exit out of the survey is probably potentially the most inattentive, right? Like, you've given them this very mild hurdle, and that was enough for them to not want to participate. So yes, definitely something that you have to check. In both mine and the replication, nobody dropped out. So again, it's one of those like conventions that you can't force someone to continue, but at least so this also could be potentially problematic, depending, I guess, on where the prompt is. Usually it's not the first thing you ask right off the bat. That's usually where I find most of my attrition in surveys is. But you're totally right that it is an assumption, and it's something that you need to check to make sure that it hasn't been violated.
Thank you.
I was also going to ask if you have looked at in a survey I was involved in, and we contracted with one of the big panel firms here in Canada, not VPL, Reagan. They actually, in addition to giving us total duration for completion, they gave us whether it was done on a mobile phone or a PC. And I think we also got browser type, like whether they were a Chrome user or Safari or something like that. So I'm wondering if you've considered looking at that, because my guess would be that you might get more typing errors in an open-ended response if someone's using their phone or maybe even a tablet to complete your open-ended response, as opposed to kind of sitting at their desktop computer or even on a laptop. So I don't know if you've had that type of information or if that's something you've considered going forward.
So no, this is a great idea. And I think, again, I'm viewing these as things as like, I can check off and convince you that it's not an issue. My initial anecdotal evidence is that, at least with regard to, and I can show you the slide probably, the correlation of the similarity measures. So I guess my quick rebuttal would be, hopefully, if there are, I guess, spelling errors, hopefully that gets washed out when we look at the word embeddings. So again, that it, like, unless you completely misspelled all the words, then if you got some of them correct, then hopefully the word embeddings is picking up the semantic similarity between the prompt and the recall. And so let's see here. The thing we want to look at is cosine word embeddings and cosine n-grams. So word embeddings and n-grams are associated at 0.87. So they're basically identifying and picking up the exact same variation. And more importantly too, and this is why I used the easier metric to begin with, is because it actually ended up having a higher correlation with the quote correct answer deemed by a human coder. So I'm hoping that those things kind of wash out. I'm forgetting, I think so typographical errors, I think, should be picked up by the Jaro distance metric. I believe that one was originally created for the census for different types of like very common typographic errors. So again, that's actually more to your point. That would only pick up issues that you have with distance on a keyboard from the letter. So I guess that could be potentially driving that, but I guess hopefully by showing you the word embeddings and the n-gram approach, that kind of assuages issues of typographical errors. But I do appreciate the idea that in general, people may be more attentive to a survey that they're taking on a physical computer than wherever they may be on a mobile phone.
Excellent. Well,
Michelle,
go ahead.
Sorry, may I ask one other question?
Yeah, by all means.
In terms of like when you were looking at this, did you consider like those surveys that offer like gift card, a chance for a gift card draw, or for payment, like if the attention increases when incentives are offered?
No, that's interesting. So I guess in this case, the incentives were all equal. Everyone was being paid the same amount of money for their responses. It would be interesting if we were to do this essentially, like you said, I am going to tell someone prior to the treatment, right, that basically it'll be a game in which they're going to win X amount of money. And then right after that, I ask them something about the story and see if that piques their attention. Yeah, no, that's really interesting. Yeah, mostly. So for the purposes of this paper, I specifically wanted to make sure that there wasn't any differing incentive to be attentive, since that's pretty much the primary assumption that we have to have, right? People can't be differentially attentive. So in that instance, we're almost priming people to be specifically attentive, but it could be interesting if it's applied to everybody. I think that's the key.
Excellent.
Thank you.
Well, thank you, Professor Ziegler, for sharing your research with us. It sounds like maybe we've generated some additional options for your future agenda questions you can answer for us in the future. So hopefully when that work comes out, we'll get to hear from you again. So thanks again for joining us. And I hope everyone has a lovely weekend. And Lynn.
Yeah, thanks so much for having me. I really did appreciate it.